All right, we're talking about Module 3.1, cross-sections and solids of rotation today. So we have some vocabulary up here. A cone, circular base, comes to a point, just like an ice cream cone. A cylinder has two circular bases. The lateral face, when you unfold it, is a rectangle. A pyramid is, the base is a polygon. It can be a triangle, rectangle, heptagon, septagon, pentagon, any of those. And it comes to a point. The lateral faces are triangles, though. We have a sphere, which is a three-dimensional circle, and we have some examples of them. Please take a moment, write down that vocabulary. We also have some other vocabulary here. Cross-section, a plane that cuts through a three-dimensional shape. We have rotation, to turn an object, but not to change its size or orientation. We have vignettes of solids, a two-dimensional layout of a three-dimensional shape. Please take a moment, pause this, write down these three vocabulary. Our first example, we're going to talk about a rectangular prism. It's a rectangular prism because the bases are rectangles and the sides are all rectangles. So on a prism, the sides will be, the lateral faces will all be rectangles, and the bases, the rectangular, means that the top and bottom are rectangles as well. We have some dimensions on here, 4 meters, 2 meters, 1.5. I also have a net drawing. So this is the net of that rectangular prism. We have 4 lateral faces going around, and then we have the 2 box ends. Dimensions are labeled. So it's like if you cut along the seams and lay it out flat, what would the rectangular prism be? If you really wanted to, you could practice with a shoebox. Cut out the sides, lay it out flat, you'd see what it was. So we're going to practice drawing a few nets today. Triangular prism, we need to talk about what kind of shapes are made up on a triangular prism. It's a prism, which means the outside edges are rectangles and the bases are triangles. Now it's not sitting on the base here. The base is the front and the back. So the front is a triangle, the back is a triangle. So we have 2 triangles. And that also means we have 1, 2, 3 rectangles. It's very helpful to know what your figure is made up of. So we're going to go ahead and draw the net. So we know that we've got the 3 rectangles going. Just like so. And we have the 2 triangles. So my 2 triangles. And this one kind of doesn't fit, but that's okay. Now, looking at this, I got to put the measurements on the net. So I know this is because it's a 14 by 5. This one here is a 12 centimeters by 5. And the same thing on this side, it is a 9 centimeters by 5. This is 14. I do not know necessarily the heights of the triangles, so I don't mark it. I take what information they gave me and I transfer that to my net. Here, I have a rectangular pyramid. I know it's a pyramid because it comes to a point. The lateral faces are all triangles. It's a rectangular pyramid. The rectangular part comes from the base. The base is that rectangle. So now I need to make a little bit of space and so that I can draw out this pyramid. Now looking at the pyramid, I have 4 triangles and I have 1 rectangle. It's helpful to understand what you're dealing with so that you can draw it. So rectangle in the middle, and off those rectangles I have 4 triangles. Now here, I know that the rectangle is a 6 by 11, so this is 6 centimeters, 11 centimeters. This side would be also 11, this is 6. Now they tell me that the height is 5. This is part of that dashed line. So if I wanted to draw that in, I would simply put the height of each of these triangles to be 5 centimeters. And of course, heights are perpendicular, and that would be the net for the rectangular pyramid. Moving on, a cylinder. So we have a cylinder. A cylinder is made up of 2 circles and the lateral area. If you were actually to undo a soda can, take off the top and bottom, cut it down, unfold that circular area, it's going to be a rectangle. So I have 2 circles and 1 rectangle. So I'm going to draw my rectangle in the middle, my circles on each side. We wouldn't want it to go through. I know that the circles are 7 feet in the radius. That means they're 14 feet in diameter. So if the radius is 7 feet, that means the diameter is 14 feet. Since this side has to go all the way around, it's going to be 14 pi. Because remember, to go around the distance, it's the diameter times pi. And then this piece here would be your height, which is the 12 feet, because that's the distance between the 2 bases. All right, talking about cross sections, next. If we wanted to describe what that cross section looks like, so if I were to take a cone and make a slice through it, the red thing here being the plane that's slicing through it, and I'm not sure if you can see it, but it goes like this. It's slicing through our cone. It's actually going to make a triangle. So the cross section here is a triangle. We're going to actually play with a few in class tomorrow, so you'll be set for kind of figuring that out. Cross sections are kind of hard to see, especially when I'm trying to draw them on the board. All right, our last little thing is we're going to describe and sketch the figure that is generated by each rotation in 3-dimensional space. So if I take this little piece here and I rotate it 3-dimensional, what shape do you think we're going to have? Well, you guessed it, it's going to look like a sphere. So it would be a sphere going around. Using those 2-dimensional figures to do a 3-dimensional object. So, get your notes down. Please use Cornell note style, and I will see you tomorrow in class.